Yo, what's up, geometry students? Let's get ready for our Unit 4 test. Trigonometry, all right triangles, scaling right triangles, ratios have to be the same. If you have any triangle with this angle W, the ratio of the side lengths has to follow the ratio of the side lengths of this triangle with angle W, no matter what the size is. We talk about the specific ratios of sine, which is opposite over the hypotenuse. Make sure you always label the hypotenuse first. That way you know which one's opposite, which one's adjacent. The tangent, opposite over adjacent. The cosine, adjacent over hypotenuse. Heads up, pay attention. I changed the angle to angle Z. Angle Z would be opposite over adjacent. Angle Z's sine would be the same as angle W's cosine. That has to be true. Complementary angles will have lots of the same ratios. So opposite. Solving right triangles, different ways to do it. We can either start with a smaller triangle with this 70-degree angle, knowing that if we type the sine of 70, we get a ratio of a decimal to 1. We can put the decimal over 1, and all of a sudden we have the sine of 70, which is 0.936. This is literally the calculator telling you the ratio that must exist in a 70-degree triangle. So you can take this and put it over 1. You say this length is 0.939, and then this length here would be the cosine of 70. That's over 1. And then we can scale it. This is one way to do it. We can see this length 12 corresponds with this length sine 70. And you could say the scale factor is 12 over the sine of 70. You could also do this with the other angle 20 degrees, and you could have said this is the sine of 20. You could have said this is the cosine of 20, and you could have said the scale factor is 12 over the cosine of 20. It's the same thing. Therefore, P must be 1 times the scale factor. Q must be the cosine of 70 times 12 over the sine of 70. And you can go ahead and plug this into your calculator if you want to. What you don't want to do is round things. You want to leave the entire decimal until the end. And we want to get our correct answers in exact form. And we want to then kind of like say there's decimals that come after there. We know this is 20 degrees. And you can type this into your calculator. And then I'm going to show you the other way to do it. If you are proportion people, this is the scaling people. If you're proportion people, let's say we have 70 degrees in this 12 and we want to find Q. We can see we have opposite. We're trying to find adjacent. I would be using tangent of 70 degrees. The tangent of any 70 degree over 1 in this triangle would be 12 over Q. We would then cross multiply and divide. You get Q times the tangent of 70 equals 12, getting you that Q is also the same as 12 divided by the tangent of 70. And you could also set up a sine of 70 degrees, opposite over hypotenuse equals 12 over P. So the ratio that must exist for any triangle in this triangle is 12 over P. P sine 70 equals 12. P equals 12 over sine 70. So there it is right there. Okay, so that's proportion versus scale. If you work with some triangle like this, you can either work with this 37 degrees, which means angle Y has to be 53 degrees, 50, 60, 70, 80, 90. Okay, cool. They have to add up to 90 because we have another 90. But if you want to just use this 37 degrees, then this is the sine of 37. This would be the cosine of 37. What's very important is to make sure you know that the sine is now this horizontal and the cosine is this vertical. 1. If you're going to scale, same scale factor, 4 over the sine of 37 would be the scale factor. So z would be 1 times 4 over the sine of 37. And then y would be 4 over the sine of 37 times the cosine of 37. Go ahead and type those into your calculator. Or if you're going to use proportions, so this is scaling. If you're going to use proportions, you're going to say that the sine of 37 equals 4 over z. The sine of 37 is for every triangle. For this triangle, the proportion is 4 over z. We get z equals 4 over the sine of 37, cross multiply, divide. We get the tangent of 37. Might be easier. Watch this, guys. If you're a proportion guy, why don't we use the fact that this is 53 degrees? Why don't we say that the tangent of 53 equals opposite over adjacent for this triangle? This is for any 53-degree angle in a right triangle. This is for this ratio in this triangle. And we just multiply. So we get that this length here is the same as 4 times the tangent of 53. It's the same as 4 divided by the tangent of 37. It's the same as 4 over the sine of 37 times the cosine of 37. Just showing you there's a lot of different ways to do things. If you wanted to use that this is the cosine of 53 and this is the sine of 53, you could have said z is let's see, it would be 4 over the cosine of 53. They're all going to be the same. Type those in. I'm not even going to bother typing it in. Cool. Now, what if we have the ratios? Here, we got this angle D, angle F, and we have this ratio 3, 6. Well, we can use the Pythagorean theorem to find E, or we don't have to. 36 plus 9 is 45, which means E is the square root of 45, which is root 9 root 5, which is 3 root 5. But how do I find angle F and angle D? This is when we need to use an inverse trig. Remember the trig of an angle, we plug in angles into trigs to get ratios, to get like side lengths. We plug in ratios into the inverse trig to get angles. So let's look at D. I know that the tangent of D equals 3 over 6. I'm going to go ahead and take the inverse tangent. So tan inverse of 3 over 6 would equal D. And we are going to get... It's really cold today. My computer might freeze. 26.565 degrees. We could take that number and subtract it from 90 to get the other one. Or we could say that the tangent of F would be 6 over 3, which means the tan inverse of 6 over 3 would equal F. We could also use sine or cosine inverse because we do have E being 3 root 5. So if you wanted to use any type of inverse, it would work. Here, tan inverse of 6 over 3 gives you that angle that we were looking for. So many options, putting dots afterwards, knowing that the decimal goes on. All right, same deal, only we're missing a leg. So we got a squared plus 4 squared equals 5 squared. We know this is a 3, 4, 5 right triangle, but we could double check. 25 minus 16 is 9. So boom. Now it's up to me, man. I could say angle A is the sine inverse of 3/5 because 3 is opposite A, 5 is the hypotenuse of A. We could say angle B is, I don't know, the cosinverse of 3/5. We could say angle A is the tan inverse of 3/4. We could say angle B is the tan inverse of 4/3. We could say angle A is the cosinverse of 4/5. Whatever you type in, you're going to get the same answer. Whether you type in the sine inverse of 3/5 or the tan inverse of 3/4, you're going to get the same answer. And if you subtract that from 90, you're going to get the same answer as the cos inverse of 3/5, tan inverse of 4/3. They're all going to be the same because it's this angle in this triangle. Ooh. What is this angle here? Well, this is 3, this is 1, tan inverse of 1/3. What's the length of the line segment? A squared plus B squared equals C squared. Square root 10. What's this angle here? Okay, cool. That angle here is the same as this angle here. You can either use a triangle with y's and x's, or you could use this triangle. It doesn't matter. This is 3, this is 5. So we could see that the tan inverse of this angle would be 5/3. 5 squared plus 3 squared equals C squared. 25 plus 9 is 34. I cannot simplify the square root of 34. 9 doesn't go into it. 4 doesn't go into it. So that's it. If you guys aren't comfortable with me leaving my answers like that, like, sorry. Okay. Ramp has an angle of elevation of 30 degrees, 13 degrees, a height of 30. The person wants to draw a scaled version to have a ramp length of 0.5. Well, so here's what's important about these problems, guys, is that there's are a lot of ways to do it, but you'll find that it's easier. Because you know these triangles are similar, you don't have to know these side lengths to know these side lengths, because you know a third triangle with a 13-degree angle. You know that a third triangle with a 13 angle would have sine of 13 as the vertical and cos 13 as the horizontal. Well, we could figure out the scale factor would be a half of this. So like I could take sine 13 and divide it by 2. Like divided by 2, or 0.5/1, which is times 0.5. So you could say this is sine 13 times a half. And then this would be the cosine of 13 divided by 2, or the cosine of 13 times a half. You don't need to find these lengths, but if you wanted to, you could. You could go and say, oh, well, this scale factor is 30 over sine 13, which means this is 30 over sine 13. And this is the cosine of 13 times 30 over sine 13. So it's like you now have 3 triangles. You got the big triangle in the real world. You got the scaled version that you wanted to draw. And you got like your calculator version where the hypotenuse is 1. So cool. All right, we got a bird flying at an altitude of 400 feet. So that's 400 feet in the sky. Right here is the bird. There you go. That's my drawing of a bird. Mr. Osborne, big O, is watching the bird with his binoculars. The angle of elevation of 65 degrees. How far is the bird from Mr. Osborne in terms of its diagonal distance? Well, maybe we set up a proportion because it's going to be easiest to find. We don't have to set up and solve this entire triangle. So we just want to find this diagonal distance, this C, this D, this X, whatever you want. Maybe a proportion is going to be easiest. I'm going to use proportions first. Proportions, it's proportions. And I would say that the sine of 65 degrees in any right triangle is equivalent to the sine of 65 degrees in this triangle. And I get that x cross multiply divide is 400 divided by the sine of 65. Now, let's say you wanted to use a smaller triangle with 65 degrees. You'd say this is the sine of 65 degrees. If this is 1, this is the cosine of 65 degrees. If this is 1, and you can see your scale factor is 400 divided by the sine of 65, which are multiplying by 1. Student stands 40 feet from the base of a building. He's in there. I think he's just at a different desk. She might be in the testing room. What's the angle of elevation? Ba-bam, tan inverse. That's it. Type that in your calculator. I'm not gonna waste my time. Okay. Lengths. Hey guys, remember coordinates? Remember lengths? Yeah, you wanna figure out the lengths? M to O. You can say like 0 squared plus 8 squared equals C squared. Oh, this is just 8. Cool. Let's go M to N. You can draw your triangles if you want to. I see a lot of students do that. If you'd like to use the table, you got plus 5 plus 4. So 5 squared plus 4 squared equals C squared. 25 plus 16 is 39. 41. 41 equals C squared. That means C equals root 41. And then NO. This is probably one of the questions you guys are like, I don't know how to do this. It's like, yes, you do. Stop it. Okay, this is going to be root 41 as well because we got 5 squared and 4 squared. So we got 25 and 16, which is 41, root 41. Cool. This is tricky. What is this height? That way we could do 1/2 base times height. Well, I'm splitting this in half. This must be 4. This must be 4. I'll have 1/2 base length of 8, height of 4. At least that's what I think it is, but I don't know that. That's a horrible, horrible, horrible assumption. This is a 90 degree, but we don't know what this angle is. We don't know that this is a right triangle. So we actually need to use the Pythagorean theorem again. You got to know that this is not a right triangle. We have to create a right triangle. We do drop down a perpendicular bisector, so it works out. Yeah, you guys are going to get this question right. But let's see if you can do it. H, a squared plus b squared equals c squared. H squared equals 41 minus 16, which is 25. Look at that. That's cool. Yeah, of course. Of course. If I go halfway up there, then like this distance has to be 5. Yeah, I'm just like gotta think a little bit. So 1/2 base times height is 20. What are the measurements of OMN? OMN refers to this angle right here. Well, you actually need to use tan inverse. So OMN is the tan inverse of 5/4. I'm going to go ahead and find that just because it's good to see that this is not a right triangle. $51.34. NOM. NOM is over here. I'm going to say theta. You can also say it's the same thing. Same ratios. You can do whatever ratio you want to do, which means the third angle, I'm going to subtract from 180. So double this, 180 minus this doubled. We realize we do not have a right triangle. It's not a 45, 45, 90. But the key step is dropping this, what's called an altitude, to make this perpendicular bisector to realize that it's not a 45, 45, 90. And I mean, also the slope would have to be like 1, and this slope would have to be -1. A slope of 1 creates a 45-degree angle because you're going over and up the same amount. That's the key for a 45, 45, 90 is like you got to go over and up the same amount. Okay, now the calculator's gone. If cosine of x is 1/4, what's the tangent of x? Well, we have a right triangle XYZ, so XYZ could be XYZ, it doesn't matter. This is angle x, and that's important. The cosine of angle x equals this ratio of adjacent over hypotenuse. You could either say you have a bigger triangle whose adjacent is 1 and hypotenuse is 4, or you could have a smaller triangle whose adjacent is 0.25 and hypotenuse is 1. I'm going to go ahead and use this triangle because it's easier to use because Pythagorean theorem with a decimal is going to be funky. So this is the hypotenuse 4. I got 1 squared plus b squared equals 4 squared. I got b squared equals 15. That means b equals the square root of 15. So this is the square root of 15. I could figure this out, but it would be messy with square roots of a fraction. Instead, I'm just going to use this. The tangent of angle x would be opposite over adjacent, which would be root 15 over 1. Cool, we got A, B, C right triangle. I don't know, it doesn't matter how you write it. We're told that the tangent of angle A is equal to the ratio. Using SOHCAHTOA, we see the ratio, the tangent of angle A, would be equal to opposite over adjacent, 3 over 1. All right, well, if that's the case, then this is root 10, because this is 9 plus 1, this is root 10. The sine of A is going to be 3 over root 10. Yeah. Don't forget our favorite 30, 60, 90 triangle that is easily scaled. That is a I forgot it. I forgot it already. I don't remember it. I don't remember. Well, you can start with 1, cut it in half, means this is 1/2. This is root 3 over 2. Or if we double everything, we could have started at 2, 2, 2, which means this is 1 and this is root 3. It's very important. The shortest length to the longest length. Know that the square root of 3 is less than 2, but bigger than 1. So we go short, medium, long, 30, 60, 90 triangle. How do we know that it's root 3? We use the Pythagorean theorem. You can say 1 squared plus b squared equals 2 squared. And you got b squared is equal to 3. So b is root 3. Anyways, this is the triangle we're going to want to figure out. So this is doubled that. So this becomes 2 and this is 2 root 3. This is quadrupled this. So this is 4 root 3 and this is 8. This is 4 over root 3 this. So like the bigger number divided by the smaller number tells us the relative size. So this is 4 over root 3 and this is 2 times 4 over root 3, which is 8 over root 3. If it's a 45, 45, 90, it's an isosceles. We get the relationship that double my legs squared being my hypotenuse squared means that the square root of 2 times my L is H, or L equals H over the square root of 2, or More importantly, if we have like L, this must be root 2L. And if you divide everything by root 2, you get that if this is H, this is H over root 2, this is H over root 2. Okay, so if I have that this is 4, this is 4 root 2, I have this is 4, this is 4 over root 2. It's that easy. And if you can't remember it, you always have the Pythagorean theorem. Cool. Small, medium, large, small, medium, large. This is 6 over root 3 times the size. So that means 5a would equal this times 6 over root 3, which means a equals dividing by 5. A lot of you are going to write it like this, but dividing by 5 is the same as multiplying by 1/5. I would write it as 6 over 5 root 3. 2b, 2 times 6 root 3 is 12 over root 3. So we get 2b equals 12 over root 3. I'm going to divide both sides by 2, and I get 6 over root 3. So that has to be b. So this is a, this is b. That's tricky. All right, if this is 4, this has to be 4. This has to be 4 root 2. I'm going to divide both sides by 9 to solve for a. A has to be 4/9. I'm going to multiply both sides by 2. 4 root 2 equals b over 2. Multiply by 2. Look at us using algebra here in geometry. Like sometimes we want to try to figure everything out, but sometimes it's easiest to set up and solve an equation. Perimeter of an equilateral triangle is 30, which means every single side length must be 10. What is the height of the triangle? Well, this is how we kind of figured out what a 30, 60, 90 triangle is. Drop this down, we create a 30, 60, 90 triangle here. This is 10, this would be 5. You could start with your smaller. Small, medium, large, times 5. This is 5 root 3. The height is 10. What's the perimeter? Okay. Small, medium, large. The scale factor for this triangle here, 10 over the square root of 3. Which means this side length is 10 over the square root of 3, or this side length is 20 over the square root of 3, which makes sense because this would also be 10 root 3. So we have 20 root 3 times. We want 3 of our 20 root 3s. Multiply straight across, we get 60 of our root 3s. Or if you add them together, 20 over root 3s plus 20 over root 3s plus 20 over root 3s becomes 60 over root 3s. But it's easier to think about this as multiplication. Like we have 3 of our 20 over root 3s giving us 60 over root 3. Okay, and that is it. I hope you guys understand things. Let's all get hundreds on this test. Don't screw up and not study. But if you're watching this, you're already on your way. Peace!